All right, welcome. We're going to do 9.4. Um, so I'm going to start with this problem, even though it's in 9.4. We don't actually really need to use the techniques of 9.4. In fact, I don't even know how to use the techniques of 9.4 to solve it. So let's do it first, and then you'll see what I mean. So we're going to find an area bounded by the curves r equals 2 cosine theta, r equals 1. Okay, so let's go ahead and find what these two things are. Okay, so r equals 1, we know what that is. That's easy enough. Let me see if I can erase that inside. Nope. Try that again. Make that a little bigger. See if I can erase the inside. No. Okay. No matter. That's my r equals 1 circle. I'm going to need that again, so I'll just leave it here. But you don't know that, not until we actually solve r equals 2 cosine theta. So let's take r equals 2 cosine theta. Now remember, from the other videos we know cosine theta is x over r, or x equals r cosine theta. So we're going to write this as r equals 2x over r squared equals 2x, x squared plus y squared equals 2x, x squared minus 2x plus y squared equals 0. X squared minus 2x plus 1 plus y squared equals 1. So this is x minus 1 squared plus y squared equals 1. So this is a circle, radius 1, centered at 1, 0. Okay, that's why I needed this circle again, because I needed to do this. Okay, so that's sort of the figure we're looking at, and we actually want to find this area. Okay, but we're not going to find that area, and you'll see why. That area is too hard to find. Or at least I don't know how to find it using the techniques that they want us to use. So instead, what I'm going to do is I'm going to do this using Cartesian techniques. And we're going to find this area. That area is going to be 1/4 of the total area that we need, right? So what is our area going to be? Let's take and think about this curve. This curve is given by, remember, x squared plus y squared equals 1, or rather y equals plus the square root of 1 minus x squared. Okay, so we're just looking at this part here. Okay, so this point here, that's actually x equals 1/2. You can tell just by the fact of symmetry, or you could set x minus 1 squared plus y squared equals 1 equal to x plus y squared equals 1, and you'll get x equals 1/2. Okay, so what we're going to do is we're going to set up the integral. We're going to take 4, because we're going to have 1, 2, 3, 4 times that integral. The integral from 1/2 to 1 of the square root of 1 minus x squared dx. Okay. Okay, well, how do you do that? You do that via normal trigonometric substitution, right? So you're going to let x equals sine of theta, dx equals cosine theta d theta. Okay, so you're going to have 4 integral from 1/2 to 1. What's that? Cosine squared of theta d theta, which these cosine squareds and sine squareds, you have to integrate them so often that it's worth memorizing how to do it. Okay, so cosine squared, you're just going to write this as 4 integral from 1/2 to 1 plus cosine 2 theta over 2 d theta. And that's an easy integral to do. Okay, so yeah. I don't know why I have what I have written here, but so you're going to take 4 times that integral. Okay, so these formulas here those are worth investing your time and never forgetting them. Okay? All right, I'll see you in the next video.